Girl, you just don't realize what you do to me when you hold me in your arms so tight. You let me know everything's alright.
Song of the day. Welcome to Tuesday. The next line is the name of the song. Somebody should be able to tell me the artist that did that song tomorrow when I return. Let's look at weighted averages. This will be fun. So this is on page 136. Hey, I was hoping for a different color. Well, okay, whatever. Let's see if we can change that color. Nope, not yet. So make sure you're on 136 so we can look at these. Weighted averages are really like mixture problems. You know, you're averaging things together that are a little different. We're going to go through a lot of these together, and I'm going to see how many I can get through. And then some of them, if they're similar enough, I will have you work through them, and then we'll go over them on Wednesday, because this is a 2-day thing to get through this. These are just that different. So I'm on number 6 on 136, so make sure your books are open and you're writing everything down. So here's a good example to start us with. This is this candy store. We have one candy at $5.45 a pound, and then the other one is $7.33 a pound. And so the whole idea is we want to make, you know, how much of this candy do you mix with 11 pounds of this candy? So 545 times 11 plus some mystery amount over here. And you want to end up with a mixture of 614 a pound. 614 a pound. And now here's the big part of a lot of these is you have to look at, you know, what you're mixing, because you're mixing things. You have this money, and then you have the amount. So over on the other side you have the money, but what you don't have is the amount. And the amount that would go over here would be the addition of these amounts together. So that would be, since we have 11 and x, that would be 11 plus x. So this should seem similar to some of the stuff we've done with equations and distributive property and things. So now I need to get my handy dandy calculator out here and do some stuff. So 5.545 times 11 is 59.95, and this will be 7.33x. And then over here I'm going to have 6.14 times 11. That's 67.54 and 6.14x. Now from this point you just need to simplify. So I know I'm going to take this 67.54. I'm going to end up subtracting this, because I would subtract 59.95 from both sides to get rid of that. So that'll leave 7.59 over here after I subtract that. And then, since I'm going to move this, the smaller one, over here, I'm going to subtract both of those. So minus 6.14x minus 6.14x. So 7.33 minus 6.14x. I get 1.19x equals 7.59. Now, if I do 7 0.59 divided by 1.19, I should get 6.38. And that is X. That would be the number of pounds that you need for that. Okay, so the big key here is you had two quantities here, and then over here you had to add them together. You'll see other ones where that is different. So let's look at the next one. Now in this one we're selling different kinds of balloons. We have the metallic balloons here, and then we have the bunches of balloons here. There we go. There's bunches. And metallic $2 each, helium balloons $3.50 a bunch. And then this says the total sales were $281, which is why I put that over there. And it says let B represent the number of metallic balloons sold. B, so B represents the number of metallic balloons sold. Okay? And then it says they sold 36 more metallic balloons than the number of bunches of helium balloons. So they sold more of these than these. So if that's B, and that would be 36 more, then over here this one has to be B minus 36. Now personally, you could do it a different way, and you could make this one B, and this would be B plus 36, because you know that more works out. I actually think I might do it that way just because it makes more sense to me that way. So 2 times B plus 36, and then the 350 B equals 281. It should all work out the same. Let's see. So I know if I do distributive property here, that's 2B plus 72. And then the other one would just be the 350B. So I'm pretty sure I can combine the 2B and that to give me a 550B. 281. Alright, well, it looks like I can subtract 72. Subtract 72. Let's see, I think that's going to be 209 equals 550B, because I'm getting everything away from B. Now, see if this magically works out well. 209 and divide each side by 550. I get 38. So that means there are 38 bunches sold, which is a good letter for B anyway, and you add 36 to that, see, that'd be 74. And that is right, but that one makes a lot more sense than the way they wanted to set it up, with this one being B. That doesn't make any sense. So that's another mixture one. You didn't have to put anything over here this time on that one. We'll have to look and see if we can figure out a reason why on that. This is number 8. This is about spending $4.57 on color and black and white copies. And it says she made 7 more black and white copies than color copies. Okay, so I could say color is X. She made 7 more black and white, so that would be X plus 7. There you go. And again, since we're not using weight or an amount, we don't need to put anything over here because this is all just money. So these last 2 money ones, you don't need to do anything on the other side. Let's see if this works though. Now, I'm pretty sure that 0.44x, and this distributive property is going to be 0.07x, and then 0.07 times 7, I think that's 0.49, if I did that right. I'm going to combine these together, add those together. That's 0.51x plus 0.49 equals 4.57. So if I take my 4.57, and some of you are maybe already ahead of me on this, which would be great, that's what I'm hoping for, and I subtract the 0.49 from both sides to get everything away from x, I'm going to have 4.08 equals 0.51x. So I'm trying to get a copy number here. I hope this works out. I'm pretty sure it will, but this decimal thing is strange. Now I have to get rid of the stuff next to x. Again, I'm dividing by 0.51 because it's being multiplied right now. So if I divide 4.08 by 0.51, I get a nice number of 8. So I'm pretty sure 8 is x. That means 8 color and 15 black and white. I guess it doesn't want to know how many black and white, it just wants to know how many color copies. So hopefully this is making some sense. Let's keep moving. Alright, now this is what I think of when I think of these mixture problems. Because here we're setting up this saltwater fish tank. It needs to have a salt content of 3.5%. And it's 20 gallons. 3.5%. I actually probably should have put the parentheses like this, because this here is the percent, and this is a percent, and this is a percent. So let me change my color here. I'm actually going to do it like this, so it's the quantity of water that we have. Now here's the tricky thing. You remember the other one we did where we had like an X and an 11, I think it was an 11 and an X, and over here we had X plus 11 because we were taking these two and adding them together to get a total over here. Well, now this is different, so we have a total over here and we don't have either quantity here. So that would be the opposite then. We're not adding something together, we're subtracting. So this one looks like this. We're just going to make one of these X. It doesn't matter which one we make X. And the other one is going to be the total 20 minus X. So again, if you remember from the problem with the candy, I think we had an amount of like 11 here, and then we had an unknown quantity of X. And then over here we had X and 11 together. So this time though we have the total quantity here, and so we have one of these is X, and the other one must be the total quantity minus that X. So we don't know, and it should all work out. But I hope you can see the difference there for that, and we'll see other ones like that too. So this is one of the main reasons we go through this. So and the other thing is it has to be 20 minus X. It can't be X minus 20, because you're not taking this and subtracting the total amount. You're taking the total amount, subtracting the other amount, 20 minus X. Okay, by now you're maybe tired of listening to me say that, but that's okay. So this here is going to be 2.5x. I know I'm going to end up with a negative 3.7x, right? Because that would be distributed there. I put it in that order to get the x's by each other. 20 times 3.7. So then I have a 74 plus a 74. Okay. Over here on the other side, I just have a simple 20 times 3.5. That's 70. All right? Don't be worried about that negative. It'll be fine. I know that I'm going to combine these, but I need to move this 74 also. Minus 74. Cancels. This over here is going to be a negative 4. And then if I do 2.5 minus 3.7x, I get negative 1.2x. Well, now you can see that if I have a negative on both sides, I can make them both positive. And now I just need to do 4. Nope, try that again. 4 divided by 1.2. Divide both sides by 1.2, and you get x equals 3.33. Okay, now you have to see where that goes and what they're asking. Because this 3.33 is x. So that's the amount of the 2.5 water that you need. To get the 3.7 water, which is I think what they ask for. Yeah, they ask for the 3.7. To get this one, you have to take 20 minus 3.33. Or basically, you got to think how much does it take. But if you don't know, just do 20 minus 3.33, and you get 16.67 gallons. There you go. Hopefully that makes some sense. But hey, there's always more. Now 10 is one I'd like you to pause the video, and try this, because it's set up like this, that you need to have 160 of the 40%. And this time I'll even do it this way. I'll even make it as 0.40. So it's 40 times 160. That's what you need to have. Then the two kinds you have are 0.25 and 0.5. So 0.25 and 0.5, or 0.50. And you're adding those two together to get the 160. So guess what? One of these is going to be x, and the other one is going to be 160 minus x. Now, if you're feeling pretty good, if this is going well, and you're like, hey, I kind of understand this, it'd be interesting to see some of you try this with this one being the x and 160 minus x here, and others of you putting the x over here and the 160 minus x over here. It will all end up with the same answers. So I'd say pause the video and see how it goes, and try this one, and then start it again and see what you get. So here's how it works. Again, we have pen time, 0.25x, and I know in here I'm going to get a minus 0.50x, and then I know this is just half, so half of 160, that's going to be plus 80. Alright, hopefully all that makes sense to you. Over here on the other side, I have the 160 times 0.4, that's going to be 64. Alright, and again, you got to keep straight which one is x, which one's not when we're done, but for now, I know that this simplifies to negative 0.25x. I'm going to subtract 80 from both sides, and I end up with, I believe that's 16, negative 16. So if I divide both sides by negative 0.25, and yours might be different depending on if you did it the other way, but I'm going to get, well, let's see, my negatives cancel out. 16 divided by 0.25, I get x equals 64. Now if x equals 64, that means that there's 64, what is this? 64 milliliters? Yes, milliliters. 64 milliliters of the 0.25, and then 160 minus 64 would be 96 of the 0.5. So the 0.25 is here, and the 0.5 is here. No matter which way you do it, you should have 64 and 96 for those strengths. There you go. And for number 11, they're talking about a boat traveling 36 miles in 1.5 hours, and then 14 miles in 0.75 hours. What's the average speed of the boat? So for the average speed, you're going to have a miles per hour and a miles per hour, and you add them together and divide by the total time. So really you can do this because there's the formula for, that says distance equals rate divided by time. And I think that's on a page back here. If I look, let me pause and find out. Yeah, it's back there on page 134, I think. This also can be rewritten as rate equals distance divided by time. And when you have something like this, you have two distances and two times. So you can actually do it like this. You can do, you want to know the average speed? Well, the rate is the average speed. You can do 36 miles and 14 miles, and then divide that by the 1.5 hours and the 0.75 hours. Okay? This one might seem pretty simple, but, you know, sometimes it just is. So 36 plus 14 is 50. So they went 50 miles, and 1.5 plus 0.75, and that's 2.25. So, you know, your whole thing is you went 50 miles in 2.25 hours. So if I do 50 divided by 2.25, I get an average speed of, sorry, put my hours there, 22.2 mph. And again, I did the rate equals the distance divided by the time, and I did both the distances divided by both the times added together, and you get that. That's it. All there is to it. And 12 is very similar. You know, you have 1.5 miles, 28 minutes, 1.2 miles, 10 minutes. It's the same thing as the last one. I think that one's part of your assignment. You can do number 12 and figure that one out. It's just like number 11. 13, now this is one of these that I just love. It has, you know, these two airplanes 1,600 miles apart. I should probably write that down. So they're 1,600 miles apart, and they're traveling at each other. And different altitudes, because we don't want a plane crash. Maybe unless we do. And the first plane is 620 miles an hour. And the other one is 780 miles an hour. Alright, and so the question they ask is, when are they going to pass each other? Or, in our math class, when will they crash into each other? So, we have two planes, start 1,600 miles apart. And they are both making, you know, so here's one here, here's one here. And they're going toward each other. So that means, as time goes by, they are both getting closer, and the miles are getting closer. So if you have the same amount of time, because you know they're going to travel the same amount of time before they crash, I mean pass each other, crash, and so really it's 620 miles per hour times some time, and 780 times some time, and it's going to all together equal 1,600. So that one should be pretty straightforward. That I do 620 plus 780x, you get 14, pen time, forget the pen, 1400x equals 1600. Divide by 1400, and you get, I think I know this one. I can't do it though, it's too hard. I'm going to cross out my zeros, it gives me more time to do 16 divided by 14. Should be 1.14 hours. Now, you know, what is 1.14 hours? That's kind of the question, is what is, so 1 hour and then 14, you know, 0.14 would be 14% of an hour, right? So if you really want to know, you could do 60 minutes times 0.14, and you're going to get 1 hour and like about 8.5 minutes, or a little under, you know, 8.4 minutes. So there you go. That's how it works. Pretty simple for those kind. They're not all like that, but most of them are. It's pretty good. And hey, here's number 14. You have ships sailing east when it passes the lighthouse, and at the same time, and there's this other ship going west. So basically, they're saying the same thing. There's a point in this lighthouse, 175 miles apart. You have two ships traveling at each other. That's just like number 13. That's the next part of your assignment, is number 14. Now 15, again, I think you should be able to do this one too, because it says, this is one of those mixture ones again, 40 gallons of the 15% iodine solution. How many gallons of a 40% iodine solution must he add to make a 20% iodine solution? Okay, so let's set this one up, make sure we know what we're doing. Has 40 gallons. 40 gallons of what? The 0.15. So 40 times 0.15, and I'm going to add to it some number of 0.40. So let's see, 40 gallons of the 0.15 and some number of the 0.40. Now, to make everything look right, I should make all the decimals in front. So 0.15 times the 40 gallons, and it's going to add that to the 0.40 of something. And they want to end up with 20%, 0.20. And so here now, this is one like that other one we talked about where you have, like the candy, you have the 40 gallons and you have the X gallons. And so if you're adding those two together over here, you're going to end up with 40 plus X. There you go, and you can solve it from there. So that's another assignment for you there, number 15. Let me see what the next page looks like here. I'm going to save some of the fun for tomorrow. On page 137, yeah, if you look at number 16, we'll go over 16 tomorrow because that one is interesting how they want you to set that one up. And it's the only one like that too, so it's a good one to go together. I think I even looked at how they solved it for that because it was very strange. Well, let's see. Let's just look at a couple more and then we can make sure we know what we're doing. And I have no idea how much time is even left. So let me get rid of that. Good, I got to make this bigger so I can see it. So number 17. This one has somebody who did 0.5 miles, 15 minutes, and 20 miles in 90 minutes, and 4 miles in 30 minutes. And then they wanted an average speed for the triathlon, miles per hour. So this is like that one where we're going to have the rate equals, we have 3 distances. So we're going to have the 0.5, the 20, and 4. I believe altogether that's 24.5, right? So we'll just make that easy, 24.5. Now that is miles. Now they're trying to confuse us, well, or attempting to anyway, with giving us minutes on the bottom when they want hours. So, but I think we can figure this out in hours because like 15 minutes, for example, is 0.25 of an hour. 15 minutes is a quarter of an hour. 90 minutes, that's an hour and a half. That's 1.5 hours. And then 30 minutes is 0.5. So if I add all those together, I think that's 2.25. 2.25 because that would be 0.5, 1.5, that's 2.25. So now to get the average speed, I would just have to do the total distance, 24.5 divided by 2.25. And I get, well, do it before I look at the answer just to make sure I did it right. This is number 17, wasn't it? Where did number 17 go? I can't tell you the answer. They won't show me. Well, hopefully I got it right because I got 10.89 miles per hour. There you go. And that's good. 18 seems to be pretty easy. You could try 18, see what you get, and then we'll go over the rest tomorrow. Hopefully that was pretty good for you, and you can get the ones that I said to do. I don't know. I think I said like 12, 13, and 15 or something maybe. See you tomorrow.